In problem number 1, we've got 6 apples and 2 pears, and maybe you recall, but this problem was screwed up. What happened was your test didn't say apples, yours said pears. So let's go ahead and deal with it like it says pears. The probability that we drew 2 pears, well, that would be 2 choose 2 times 6 choose 2 over 8 choose 4. And that would give us a probability of 3/14. And so then what's going to happen is I'm going to go and I'm going to use the calculator and use combinations and figure out the other possibilities in a very similar way. And you'll notice how I've got the calculator all set up, so I'm just not rewriting the whole problem. I'm just changing some of the digits. Anyway, I'm going to get a probability distribution of 0, 1, and 2. And the first one is going to be 3/14, 4/7, and then 3/14. That's my probability distribution table. Now in part 3, there's where things go awry. What happens is when I go to try to find the variance, I go and use this, I square times the probabilities, and I subtract 3 squared because they are nice enough to give me the expected value as being 3. And the problem is there's no way the expected value can be 3. And we end up with a negative variance, which is impossible. And if you take a look at it, think about it. The expected value is 3. That isn't even one of the choices. The choices are only 0, 1, and 2. Whoops. So here, let's take a look at this. If, in fact, we had done it with apples like we were supposed to, well, then I would have done 6 choose 2 times 2 times 2 over 8 choose 4, which gives me the same probability. And see, in my defense, what happened was someone did point it out during the test that it didn't make sense. So I went back and I worked the probabilities, not looking close enough at the rubric. And the probabilities were coming out to be exactly the same as what was written on the rubric. So I didn't think anything about it. And so it should have been, though, 2, 3, and 4. With the probabilities being what's up here. And if we would have used those, well, the expected value would have been 3. If we would have taken off the expected value equaling 3 and made you figure that out, then the first part would have worked out. So anyway, what happened was I did not use any of the, I only gave points for parts 1 and 2. I didn't even look at part 3 when giving points in this problem. So then what I want to do is I want to show you the rubric. But keep in mind, it won't make total sense because, like I said, I wrote the wrong word. I'd switched apples and pears. And I gave you a different problem than what this addresses. Anyway, let's go ahead and take a look at the next one. In problem number 2, it says we've got disposable face masks and they're sold in packets of 15, and a faulty face mask occurs, and they said they've got a random, they get the average number or the expected value of faulty packets as being 1.2. So basically what's happening is they're giving us the expected value. So what's going to happen is if I know that the expected value is equal to 1.2 and n times p is equal to 1.2, well, if I go now and figure out the variance, that's n times p. I can replace that with 1.2, but then I need 1 minus p. Well, then all I've got to do is take a look at my n, and I use the n times p formula equaling 1.2 and get the p by itself, and I find out that p is equal to 0.08. So that means that 1 minus p must be 0.92. And when I multiply 1.2 times 0.92, I do get 1.104. Now in part 2, it says find the probability that a packet contains at most 2 faulty masks. That means the probability that X is at most 2 faulty masks. Well, that's going to be less than or equal to 2. And so now all I've got to do is figure out the probability that X is equal to 0, X is equal to 1, or X is equal to 2, and then add them all up. So let's go ahead and do that real quick. What I'm going to do is just quickly jot this down and note what I'm doing. I'm not putting the exponents because there's patterns here. And so once I've got this, then I fill in the exponents. And now I'm going to let the calculator do all the work. I call that up. I go to menu 7. I pick number 2. I plug in the variables 0, 1, and 2 and the probability. And then all I've got to do now is copy these down. And then I'm going to go ahead and add them up. Now, it's not a big deal, but you also have the capability, if you use the calculator, if I use this binomial CD, it'll tell me everything down below a certain number. And so you'll notice how I get 0.87. Well, that's going to be the same number if I add these 3 probabilities together, which most of you ended up doing. And that's going to be our answer, 0.887 to 3 significant figures. Now, this next part says that we've got 8 packets of face masks at random. Find the probability that there are exactly 7. So now we've got 8 packets. That seems to be the new number of trials. And so what we've got to do is we've got to figure out the probability that at least one packet's got there's at least one faulty face mask in a packet. Well, the probability of a face mask being defective in a packet, that's 0.08. So what we've got to do is figure out what probability of 0 of them being. Because the probability of it being greater than or equal to 1, that's the same thing as 1 minus the probability of x equaling 0. Well, I know what the probability of x equals 0 is because we just figured that out a minute ago. It's right up here. So all I've got to do is, and you can see it's just really 1 minus 0.92 to the 15th. I can just go ahead and do that, or subtract what I'd already figured out, and I get the probability as being 0.7137. And see, now I'm going to use that probability to answer their question. I've got 8 trials, 8 packets, and I need to figure out that exactly 7 of them, the probability that exactly 7 of them has got at least one faulty face mask. So now what I'm going to do is I take this probability that we just figured out, raise it to the 7th power, and then I'm going to do 1 minus this probability and do that to the 1st power. And I could use, the menu 7, but in this case, I can also it's probably just as fast to go ahead and type it in as long as I'm careful. And so I go ahead and do that, and I get the probability of being 0.216, and there's my answer. All right, so again, let's take a look at the rubric. You'll see that the rubric, it shows pretty much what we're talking about. It shows this formula. If you attempted to do that and you get this, then I can give you a method point. And then after that, you've got to get it right. And in part 2, if you use the method, if you can show me some kind of reasonable binomial expression, and then if it's correct with 0, 1, and 2, well, I can give you a point even if you don't end up with the right answer. And then, of course, you get the 3rd point. And then the last one can give you a method point for trying to figure out the probability of it being 0 using 1 minus, and then somehow doing 1 minus something or other. Then if you go ahead and try to use that, I can use a method point. But that's how the points. That was a tough one. You get worth 4 points. All right, so let's go on to the next one. Question 3 was a pretty straightforward one. All we've got to do is figure out what this k are, and then we know the probabilities must equal 1. So we add them up, and then we subtract from 1, and so we get 3k, and then what's this, 59, 5, so that's going to be 0.64. Take away 0.64 on both sides, we get 0.36. K is going to equal 0.12. So then this is going to be 0.24, and this is going to be 0.12. That's my value of k, though, is still 0.12. The mode, I just got to find the guy with the biggest probability. That's x equals 1. He's got the biggest value, or the biggest probability. And then in part 3, find the probability that the number of candy bars is bigger than the expected value. So I got to find the expected value, which is going to be 1 times 0.35 plus 2 times 0.24 plus 3 times blah, 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 blah. All I got to do is add those up, and I get a, let's try to do it. Let's see what we get here in the calculator. I'm going to get the answer as being 1.39. Now all I've got to do is find the probability of it being bigger than 1.39. That's the probability of 2 and 3 and 4. So that's 0.24 plus 0.12 plus 0.05. And that's going to give me an answer of 0.41. That's part 3. And then quickly looking at the rubric, you can see it's pretty straightforward. If you tried to get the k by adding them together and equaling 1, I can give you a point. And then in part 3, if you tried using a reasonable method to get the expected value, I could give you a point. But other than that, I needed to see what was written on the rubric in order to give you any points. All right, let's look at the next one. In question number 4, we've got a game, and we're throwing 2 die, and the numbers are added together. Now, they want to know the probability of the 2 die equaling 4. Well, you could make a possibility table, and a lot of you did, but this was pretty easy to figure out. The only way to get a 4 rolling a dice is a 1 and a 3, and a 3 and a 1, and a 2 and a 2. So that's going to be 3 out of 36, or 1/12. That says in part 2 that we're throwing it over and over again, and we want to stop when we get the sum of 4. So that means it's going to be geometric. And if it's geometric and they want to know the expected value, all I've got to do is take the reciprocal of p. The expected value of a geometric distribution is 1 over p, so 1 over 1/12 is going to equal 12. And then in part C, it says find the probability that the sum of 4 is first obtained on the 6th row. So that means we're talking about the probability of x equaling 6. That means we had 5 failures and then 1 success. So it's 11/12 to the 5th times 1/12. And when I plug that into the calculator, I get my answer of 0.0539. And then we just write that down. And the next thing it says is part D, find the probability that x is less than 8. Well, we got that cute little formula that we could use, but it's less than or equal to, so we're going to switch this to probability of x is less than or equal to 7. That's 1 minus fail to the 7th, or 1 minus 11/12 to the 7th. And all I got to do is put that in the calculator, and I get my answer of 0.4561. And there you get the rubric, and you can see it's pretty, there's not much playing around in this one. Either you got the right answer or you didn't. The only method point you could do was in the last part D for trying to get that fail correctly. But that's about it for this one. Let's go on and look at the next problem. Problem number 5, it says that Charlotte's got 12% of all trucks are owned by women. And then we looked at 19 trucks at random. And so that means that we want to find the probability that fewer than 4 of them are owned by a woman. Well, that means I need to find the probability that x is equal to 0, x is equal to 1, x is equal to 2, or x is equal to 3. So all I'm going to do is write this down here. And once I get it all set up, I'm going to plug it into my calculator. Whoops, be careful. Put the exponents in the right spot. And once I get this laid out, I'm going to go to my calculator. I'm going to do menu 7 and not geometric, but binomial. Let's do the right one. Put in my list of 0, 1, 2, and 3. That'll give me each probability, which I do want to write down. So let's go ahead and put this in. 19 probability is 0.12. And then I'm going to go ahead and scooch this over so I can just see these. Okay, probabilities. And then all I'm going to do is add them up. Now, I think I mentioned this before, but we also have on our calculator the binomial CD. That'll find the cumulative probability of everything below it. So you might want to use that. Let's make sure we got the right things. But if I do CD, and then you'll notice that the variable are already in there, and it's going to cumulative. So notice how the probability of 1 is the same, but the last one is going to be all those added up. And the other thing is, it may be a little time saver if there were a lot of them, but you can see if I add up these probabilities, I'm going to get the same exact answer. All right, so now it wants to define us the expected value and the variance. So the expected value for a binomial is n times p, so that's 19 times 0.12, and that's going to give us 2.28. And then to find variance, all we've got to do is multiply n times p times the probability of failure, which is just 2.28 times 1 minus p, or 0.88. And that's going to give us a variance of 2.0064. All right, and there's our rubric. Again, you can get some method points for trying to do the right thing if you show me a reasonable binomial distribution with the numbers. And if you go ahead and get one of the terms correctly, then I can give you a point. And if you have all 1, 2, and 3, and at least 2 of them are right, you can get another method point. And of course, to get 4 points, you got to get it all the way right. All right, I hope this helps. Oh, also, this wasn't on the part. The expected value and the variance wasn't on there. I added on there, so I just gave you points accordingly. You either got the expected value or you didn't. And then variance, if you did the right thing, you could get a method point and then get it the right answers. That was only worth 3. All right, thanks for watching.